Hey, and welcome to my talk on cognitive engineering, Shift Right, Digital Twin, featuring the gated AI methodology. So I'm really excited to be here at DevOps Next online conference. Of course, this has been pre-recorded to avoid technical glitches, but it does mean that my digital twin or digital Jonathan will be answering your questions in real time in the Slack channel right now. So go and ask me anything as we go through this whistle tour introduction to my chapter in the book. Okay, let's kick this off. So go and check out my TED Talk. So go to TED.com and type in Jonathon Wright, or look for the title Cognitive Learning, Evolution over Revolution. And it'll give you a brief introduction around digital mobile and the challenges that we're going to be talking about today. So as you can see in the background right now, I've got a whole stack of technologies, which I kind of class as this kind of cognitive engineering landscape. So that ranges from the digital experience analytics that I talked about in the first book to kind of this paradigm around Shift Right, which is what features in the TED Talk. So I'm going to go through a few of these, but I want to give a bit of pretense. So I've actually was a part of doing the original digital quality handbook with Iran and all the guys. So I've actually got a copy right here with me right now, and what if you turn to page 19, you'll be able to check out this diagram which I've got at the background, which is about cognitive technology. So cognitive engineering is the ability to start testing this kind of technology through a design and build methodology, which I'll be going through in a bit of detail. So two of those I've just highlighted, and as you can see, one of them is about complex event processing and city data exchange, both projects that I worked with Irang and the R&D gang, Uzi, at Perfecto. So some amazing work that we've done in the past. So I'm going to rewind all the way back to 2015, right? And I know people are going to be talking about AI, machine learning throughout this. So I wanted to kind of give you an idea of some of the project work that I've done. So as you can see in the background, we've got Washington, D.C., and of course the White House, and we were using predictive crime back in 2015 based on a huge amount of data to work out, or what we kind of class as these complex event processing. So things like video analytics, looking at loitering algorithms for behavior, whether people were parking too long, looking over a restricted fence. So all of these different feeds coming through, plus historical information to give us this ability to do prediction. So these are the kind of complex systems that I think the old approaches and methodologies that we used in the past probably aren't going to be sufficient in the future. So back to 2015 again. So my first kind of involvement working quite heavily with the guys at Perfecto was around, I guess, what you would call contact tracing early on in its career, around creating a smart city mobile app. So this application, as you can see on the left hand side, was designed to help reduce your CO2 emissions. So it had this idea of recommending the most carbon neutral way to work. It would tell you the actual efficiencies, so you could have your your dashboards. But more importantly, we tried to bring in, with the smart city data exchange, this idea of gamification around challenging other people, whether that be based on employers, helping them have tax reductions, or against other people within the city. So there were 36,000 people who, when we launched the app, had to be able to use this mobile app, and it's thanks to the guys at Perforce to made that possible without any glitches. So smart city data exchange back in 2015. So how did we do it, right? I guess is the big question. So as you can see, 2015 in the bottom right hand corner here. So this is a script which we developed, which took GPS information, or GPX information. So you see in the longitude and longitude in the bottom left hand side, and injecting it into real devices. So this was really kind of that first step towards how do we synthetically generate data at mass scales to replicate historical information, so that we could get the gamification aspect. We could also train the algorithms to recommend the best routes. So how did we do this? Well, in our first case, we used synthetic data that we generated via TDM platform that I ended up working for in Santa Clara in Silicon Valley, dealing with similar kind of challenges and similar problems for people like Apple and PayPal, who were also developing hugely complex mobile apps. So, part of this landscape is we took some deltas, which we actually paid the students of Copenhagen in beer to go off and have a GPX logger to go and get that information for us. And then we created synthetically 2 billion historical transactions, which is why I'm going to talk a little bit now about the something that's very close to my heart, which is the COVID Safe Paths or Path Check Foundation. So again, I was pulled in based on my work that I'd done with Perfecto back in 2015. And I was asked to contribute to with MIT on an open source platform for both GPS and gains. But we had the same problem. Obviously, people was isolating, and this, as you can see, is back in March when I started in my involvement with the project and helping lead the QA efforts in testing in production. We didn't have people walking around the city. So you can see from this diagram here, and I'm going to do a little bit of a demo in a second. These are historical transactions that I've done over the last 10 years, which I took from Google Takeout. So I'm going to show you how it all comes together. So as you can see, this is your exposure notifications, which you get within the mobile app. So I'm going to give you a bit of an idea. So if I'm capturing all these locations, which originally was GPX information, and then we moved into using gains, which I'm going to talk about in a little bit more detail later on, which is your beacon data that you're passing, proximity information you're passing. But this one here, you'd share your location data, so you'd share that with your health authority, and then they would go through and understand that GPX information and cross-reference it as part of, again, a very similar to the Smart City Data Exchange. So what did that look like? So these, you can see Boston, Massachusetts there, and thanks to Iran, who shared his Google Takeout data. But I'm going to show you a set which we synthetically generated with the deltas from my Google Takeout data, and loaded into the path check redaction tool. So the idea behind this, because we were doing privacy by design, we wanted to be able to go off and maybe redact information like your personal home or your workplace, any identifiable data. So as you can see, this is loaded in a 9-day kind of window of activity where I again, this has been synthetically generated, and you can see me going around Knightsbridge at the moment. And obviously I've not been to all of those locations. They've been created, and I can now remove them. So if, for instance, that was where I was working on a particular client site, which you can see is the center of everything there, I could redact that, and I could remove all that identifiable details. But also when I look at travel, so you can see I've unticked travel, it's removed all the travel locations. So if I hover over a particular item, you can see the speed I was doing versus being somewhere that I was stationary. So that's the data which I've taken, and I can extract that out. And the idea with the redaction tool is once it's been extracted, it could then be published back up into share that information. So obviously if I'd been exposed, they could correlate that against other people's data sets. So that was kind of the first challenge we had back in March. And as things have moved on, we've been working quite closely with Apple and Google to work on gains. So this is obviously another approach. The great thing is that this is getting rolled out to every device. Now, of course, there's some challenges around each one of those devices needs kind of optimizing because they've all got different tolerances. So there's a lot of challenges out there, which is why some other applications like the NHS app in the UK, which I was involved with, they tried to do the gains technology. And they had some real challenges, but again, it kind of shows the importance of actually having devices, but also being able to have them at a certain distance away from each other for the proximity. So we've been involved in Perfecto since the start of this project, and it was only because we were able to use their technology. So I've actually got a whole stack of devices using the Apple development kit, iOS 14, 15 to be able to and the actual Apple silicon technology, so I can run it natively on that platform. But I'm using these Macs sat across in different positions in my house, so I can bring devices closer or further away. So these kind of challenges really require real devices and not emulators, which is the challenges we were having with the guys at MIT. Was how do we test this kind of technology? So yeah, just in case you don't know how this kind of works, the idea with Gains, and it's because it's already installed on it's embedding into the iOS level. They can automatically exchange your identifiers by Bluetooth, and therefore, if you are infected, then you just load on our app, which is the PathCheck app. And then you're able to push that using two-factor authentication to your health authority, and they're able to push notifications to everybody else who you've been interactions with. So I guess this is the call to action, which is anybody who's got multiple devices, preferable, especially for Gains. But if you don't, it's fine. We've got the Perfecto Cloud. Anybody who's familiar with this kind of technology, we really need your help, because there's a lot of items, not just your traditional kind of automation and functional testing or performance or security. There's localization testing. So as you can see here, we're doing localization testing with different languages. Because we're rolling this out to 20 odd different countries at the moment. The idea is those countries, for less developed countries like Nigeria, our test site was Haiti originally. We do a lot of testing in those different languages with crowd. So anybody who's available, come and help make a difference. Like I said, massive thanks to Iran, who provided all his historical data across Boston, which we're able to then synthetically generate data for the test when we ran it in that local area with Massachusetts Health Authority on board. So, again, if you can help, that would be fantastic. It's a big kind of testers assembled. Iran, thanks again. He's been involved with discussion panels with leading experts, looking at different approaches with the guys at MIT. I even put a bit of fun in there with doing VR meetings. So, shameless plug here. I've got the book with me, so massive thanks to Iran for sending this over all the way from Boston. Obviously, if you go over to 227, that starts my chapter in the Accelerating Software Quality book. So make sure you download this today or get it on Amazon. Also, a quick promotion for those ones reaching out to all the community to bring us all together. I've just done another free book, which is Around the World in 80 Testers. So check that one out as well to reference. Also wanted to kind of point out the how important this is, and add those links that I kind of said I would do. So the safepaths.mit.edu, the pathcheck.org charity, both of those bit.ly links I created, which will invite you into our Slack channel. You'll be able to fill in the MIT volunteer form. When I started this back in March, as you can see it here, I use this dashboard, and you can just see how it's changed from what was 2.5 million cases and 170,000 deaths to right now, while I'm actually talking to you, the latest numbers are 27 million and nearly a million deaths. And obviously you can see the information there around the confirms in the US. So this is kind of the perfect time to get involved with this project. So anyway, that aside, let's move back to kind of the book and what we kind of covered in the book. So Shift Right was a concept that I've been talking about for about 10 years now. And it's something close to my heart, which is why I kind of, from the TED perspective, I wanted to kind of talk about this ability to do the think, make, and learn aspect, and where we've got to get involved in this. So if we think about the historical kind of landscape of linear software design, shall we say, for a second, and even with Agile and this quick kind of build and test, which the guys at Hewlett and Packard have been doing since the early days of the Valley, actually things haven't really haven't really changed. Or yes, we're iteratively doing the design, but it still seems like we're missing this feedback from operations. So this right hand side here around how do we get information back to validate what we're doing is correct. So part of this is, I'm not saying it's a replacement for shifting left, i.e. getting earlier within the life cycle to then be able to identify things quickly and resolve them. But actually, I'm saying that actually it's as important to get information at the end and feed that back in as well. So quick kind of point on those three segments that I kind of highlighted as part of that talk. So the think, evolve and learn. So evolution over revolution. So starting with the kind of the thinking aspect and the learning aspect. This is where the real challenge was how do we get this feedback from learn back into think? And to me, this was a perfect opportunity for the platforms that are appearing in AI operations, but also some of the approaches that we're using to make decisions from a thinking perspective. So my friend Ray Arel did this great kind of, how we're validating ideas. So your kind of lean startup approach, how do you quickly prove a hypothesis? It's those kind of challenges that we're kind of looking at and trying to resolve, right? So start with the thinking kind of aspect in, how do we fail fast, learn rapid? The whole point of kind of this DevOps methodology is to give us that speed and enablement, right? So part of it is, also how do we inform what we're doing based on, a model or observation of what we're expecting. So things like model-based testing is really helpful for creating a model, and I'm working on the new ISO standard for that at the moment, but also part of the ISO committee for the new testing of AI systems. So this is the thinking aspect, and I think this is then when we kind of say, okay, well, we're very used to this kind of building and testing, should we say? So design, develop, deliver, disrupt. Very simple. And yes, we're very good at this kind of BDDA, TDD approaches on the left hand side for design and build. We're doing really well from a CDD, so a continuous delivery and deployment perspective, and being able to get things into production really quickly. But how do we understand what's going on that right hand side? And I think this is the big challenge, and there's so much information on that right hand side. So how do we potentially provide that feedback? So I think the easy way to look at these things, and I've been talking about this kind of concept of an adaptive data store for many years, which was this kind of how can we feed into things like the repository. So looking at the GitOps approach, understanding the code maps from the apps, understanding and doing the prediction around release management and unbreakable pipeline. Your environmental management aspects, so your schema and Avro and how that's all set up and what that looks like in your container landscape or your pods. Getting information from your network management systems, your infrastructure management systems, any system which you can pull data out from and feed that intelligence, that information, is a great candidate for this kind of approach for shifting right and learning, which is kind of, like I said, the AI operations kind of landscape. So again, when I was working for a vendor which worked quite closely with the Perforce guys, and we used to do this with their technology, and I can give you a really good example when I was demoing this to Diego at Forrester, and part of it was I said, okay, go off and do something on a newly built app, so that the app got promoted all the way through the CI/CD pipeline, and then it was a brand new app. We obviously had an analytics platform looking at it. So he went off, Diego, on his iPad Air in Germany or wherever he was at the time. He kind of went and explored the application. And I said, later on, about 5-10 minutes later, I said, okay, have you finished? He said, oh, yeah, I've done that. And we were talking about other stuff at the same time. So I quickly generated an MBT, a model of what that system looked like. And I said, so this is your flow. So you kind of went in, you registered, you ordered this, you did that, blah, blah, blah. Okay, that's great. which is easy because it's just the request response pairs that we're capturing and we're understanding from like a pinpoint failure analysis, root cause analysis perspective. It's very simple stuff. So we took that model, and then within a few seconds we reran that using Perfecto, pushed it to, which spun up an iPad. It ran the same timings, it did the same screens, functional testing, not exactly difficult, right? So, but what we wanted to be able to do was this kind of, and we ended up calling it the improbability drive from Hitchhiker's Guide to the Galaxy. But what we were able to do is we're able to synthetically generate millions of different tests going through all paths through the application using our MBT from that original kind of understanding of the activity Diego had made. We were able to go through and say, well, what's all the different permutations we could go through the app? What's the different permutations we could go through the data? And the example we gave him is, he said, well, actually, if you'd registered as, as Scotland and then gone in and changed your profile to, a new address and then tried to order something, but something would have crashed. And he was like, okay, well, that's pretty hard to find. And also it's the model-based data, which is important because it's the data that's changing. The functionality or just going through the application with the same data isn't going to find that, which is, nothing new. So, part of it is trying to go through and creating more data to give us, from a kind of a standard graph theory perspective, closer accuracy of what the actual problem was that caused the break. So, this was this kind of concept around pinpoint failure analysis and the ability to automatically generate tests based on a model that's learned from a production environment. And we've been using this for the UK government. We've been using it for all sorts of different new challenges with that same kind of, approach. So, cognitive learning and taking that information from the right-hand side. So like I mentioned, for the UK government, we did this for Brexit. So we had to be able to take what's happening at the moment and then look at what would happen in a no deal situation, or in the case of now with COVID, how people are using the system in a slightly different way. So they may be trying to get tax relief for employment, new tax codes, furlough, etc. So the behaviors on the system are changing, and what we're doing is we're changing how the system's used. So therefore, we want to be able to understand and create a model based on that user behavior. So we had to be able to create two scenarios: one for a deal situation, one without a deal, which didn't exist at the second, and we needed to prove both of those systems without going and costly, from a government perspective, implementing all the systems that are required. So, part of the challenge which we had, there's a couple of things that I've been doing quite recently. So this idea of hypercube baselining, which a number of the AI ops platforms use, where you've got this huge amount of multi-dimensional transaction data, which is that coming from different users. It provides a very unique picture, and it's a huge amount of data, and it takes a huge amount of storage. We can use that data to create these learnings and these models. So there's a number of companies that will take that cube and move it to the left hand side and generate all permutations of the model. So that's the kind of things that we've been doing, and then we can use kind of chaos engineering approaches through the CI/CD pipeline, but also from on the right hand side in an operational sense, which is this kind of learning aspect we're seeing on the right hand side on behaviors and experiences. And those could be digital experiences, those could be M2M, they could be nano services, they could be lots of different transactions. We're using this kind of dark canary approach, which I've kind of been trying to coin with this, which is kind of dark launching and with canary rollout, which allows you to kind of say, okay, we want this amount of users to prove this hypothesis, so we'll check those guys. I know Amazon do things like dark launching and canary rollouts. It's all very basic stuff now, but part of it is using this model to then be able to get people in the real world to be able to validate this very quickly without having a massive impact. So taking information to change the behaviors, to understand the behaviors, and then model them so that we can test them and also measure them. So a lot around that final learning, and bringing that learning back into making decisions about the system. So I'm going to flick through this really quick because I don't want to spoil anything for the book, but I wanted to kind of give you a bit of an idea about the gated AI methodology component. So again, testing a lot of these AI-based systems, the challenge was, okay, obviously you can't just put an assertion in there and say, is it this value, because, it changes with every time every version of the algo, or, what you're trying to do. So, easy example with the predictive crime aspect and the predictive, where areas are going to be for COVID. So if it was, it was a big event that was happening, to be able to predict that, you'd need that historical data. So, it's never as simple as as always having the same answer. So gated was this kind of approach that we started building, which was this kind of goal. What is the goal of what we're going to do? We've been doing this for Amazon and eBay and stuff for just basic computer vision capabilities to recognize products. So the idea is that you'll be able to see. If take Instagram, so you're wearing an Oxford hoodie, you want to buy it, you can click on the person who are in your social media, and it would then go and find the place where you can buy this jumper from, and then actually continue the purchase without ever going out to a retailer. And these are the kind of technologies which people like Facebook and Instagram are using at the moment. And we were doing this with video as well, for live feed video, so as a bit like the old days of buying from TV. You could see models wearing outfits. Okay, I want to buy that, or I want to buy those shoes. So using that computer vision kind of capability to correctly identify products and also take you to that kind of location with a certain level of accuracy, right? Because there's so many sub channels and subcategories. So ex-boyfriend jeans versus boyfriend jeans being baggy, the other ones being ripped. How do you do those categorization and subcategorize? And then there's different subcategories in different countries, different color codes, different sizing codes. So obviously massive graph, DB for a knowledge graph we were using for Neo4j. So part of it is, okay, well, we need to be able to do this, and we need a clarification rate of over this, because otherwise we can't augment that with something like Amazon Turk. If it's, we want to get we don't want to be paying for it. We want it to be able to be recognized by the system, right? And then we've also got a certain amount per day. So we'd have big vendors, so your Nikes or Superdry, whoever it may be, who would want to give you a whole stack of images and SKUs and say, go off and list all those products. Okay, no problems. Well, how many we got to do? Then decides how long you can use from a compute power. So there's a time frame to that. As we'll see in the next example, is you may be able to improve your clarification rate by a couple of %, but in actual fact it's going to take a few minutes per image to actually then go off and refine. So there's always overtraining of algorithms. So time frame is being important. Enrichment, so what we kind of class as semantic models, but it's just data engineering. The old ETL landscape of something that's been around forever is how do you mine an ecosystem to enable kind of an AI test data lake, shall we say, which is this ability to kind of say, let's train the system with data that we can control, instead of just going and looking for pictures of genes and then training it with that. So again, that kind of links to the D aspect, which is obviously the most important bit, which is the training data and how you split that. So what's the training set, which you've got how many images it is, for development, testing, proving sets, etc., at what kind of quantity, which again is a massive challenge. So breaking these ones off very quickly, and obviously you can read the book. We know how TensorFlow or OpenCV works. It's all fairly standard kind of technologies you can get now. Okay, we use some computer vision, and we want to be able to categorize images. A dog sat next to another dog, or something like that, right? It's the same kind of thing in the fashion world for outfits, etc. So the first requirement was obviously, and then maybe the most difficult to kind of explain, is this. Well, what does good look like? What does enterprise AI be at an acceptable rate for it to be feasible, right? With X amount of, how little amount does the data set have to be, or how many images do they have to provide of a particular product before we're able to kind of get a positive? So obviously you've got there in the bottom, you've got actual negative, actual positive. Where do we want to fit under the curve, right? So again, we set ourselves a rate, and then partly, like I said to you, it's you're going to get different stuff. So if you've got you've got some percentages of accuracy. So let's take the 70%, 75%, and 67. You can see at the bottom, and then you can see how long the time is for training. Downloading, pushing it through the system. Okay, well, even though we get an extra 2% out of Model 3, actually Model 2 is probably the best option for us because it takes less amount of time and it's got probably the best. So it's understanding that trade-off. And this was a bit of a challenge for us because the way we started this project is that we thought, oh well, what we'll do is we'll just go off and train this, use something like the Amazon, the computer cognitive services from Microsoft. So you can see there the vision platform, which will identify pictures of handbags. What we could do is feed it a whole stack of pictures of social media of handbags and use that as our training set, and that then became a bit of a challenge because we realized that actually it wasn't giving us the level of accuracy that we wanted. So in actual fact, we started it based on the back catalogue of the company that was approaching us. So if it was Nike, we'd harvest all of their ERP, CRMs platforms to get as much metadata out as possible to help with the enrichment, and also a whole stack of images because, as you can see, they're easier to categorize if they're a particular color or particular style of photo which the particular vendor would use. So we would go off. We'd grab this huge amount of data and harvest as much as we could, which was kind of, I guess, context sensitive as far as whoever the vendor was. We got a better understanding of the test data that we had to go and get, and we would then also try to enrich that data. So if we've got some very basic information like an Apple iPhone and a SKU number, we can enrich that data because we know there's information about it. So therefore we end up with more data, which helps us really understand the category mapping and features, etc., etc. So very simple approaches, nothing groundbreaking, but actually really helped us improve what we were doing. And then other methodologies that we were kind of doing. So we kind of said about test data and the ability to synthesize test data, which we did for the GPS. It was a similar kind of thing around being able to generate and harvest data, whether that be just transposing sites, using spiders to go through. One of the things we're doing at the moment with Watson is we're taking a word and then we're creating a graph out of the back of the context of that. So if you're saying, a reversible jacket, we can understand the context of that and enrich that information a little bit more. So, there's plenty of ways to look at this. And I think, this is the gated approach is a good way of creating a basic kind of approach to, okay, it's no longer just a pass or a fail. It's, okay, well, was the accuracy over 70%? Yeah, and this could even be as seen as your acceptance criteria. If you were doing a ATDD kind of Elizabeth Hendrickson kind of approach to things, you might be saying, oh yeah, it's over 70%. We're going to do over 10,000 images per day. We're going to get the data from all these internal systems, and we want training data sets of about 5 million or 10 million or whatever, and we have this amount of parameters and so on and so forth. So you can make a decision quite quickly, and so the example which I ended up doing for a new biggest growing fashion retailer in the UK, how can you differentiate between these two pictures? They're both evening dresses or whatever the categorization is, but one more looks like lingerie than the other one. So it's very difficult to run these kind of systems through, and that's where your augmented intelligence from things like Amazon Turk is really useful, because then you can help by aiming with people who actually have fashion experience and know the difference between these different styles, which I personally don't. So yeah, like I said, looking at the different models, past was the Model 2, it gives you an idea of a way to just create a simple test for us. So, I want to thank everybody for listening. I hope you enjoyed the book. I hope you enjoyed the chapter. More than happy to kind of get any feedback. Obviously, virtual Digital Twin Jonathan is on the Slack channel right now. But if you also want to subscribe to, say, theqalead.com, podcast every couple of weeks. We talk about all this kind of stuff. So yeah, and if you want to reach me directly, it's just linkedin.com/n/automation. So enjoy the rest of the day. It's a fantastic lineup, and thanks again.